Okay, good morning, students. So we will continue with the standard form of EM in terms of modulation index. You already studied that total power is always equal to PT is equal to carrier power plus sideband, total sideband power. And this can be further divided into carrier power, carrier power plus upper sideband and then lower sideband. This is your equation. Now you already derived the value of this PC and sideband power from the equation of standard form of AM. You know the standard form of AM. Okay. Are you getting me? Hello?
Yes, yes,
Yes,
sir.
Okay.
sir.
Please do respond. Okay. So this is equal to AC cos of twice pi FCT plus AC, this is MA modulation index. It's equal to AM by AC, right? This we have studied yesterday, and its value can be between greater than standard value. If this is greater than 1, this is called as overmodulation, right? Done? And its value is 0, that means this is unmodulated. Modulation does not happen. And its value can be 1 also, or in between 0 and 1, that's standard form of modulation. So it can be also 1, that's called critical modulation. So ultimately value will be equal to ACME divided by 2 cos of twice pi FC plus FMT and plus ACMA divided by 2 cos of twice pi Fc minus Fmt. This is your standard form of equation for amplitude modulation. Okay, so this is nothing you can just write in terms of power values. This power value is carrier power and it's equal to AC square by 2, because AC by root 2 will be its RMS value. RMS value square will be power, and its voltage divided by R. R value can be taken as 1. So instead of R, this can be 1. I didn't write anything. So you can say this is AC square by 2. Similarly, for this component, this is your upper side band. You can say upper side band value is equal to ACMA divided by 2 ka whole square divided by 2. So this value will be equal to AC square MA square divided by 4 into 2, that's 8. Similarly, this value will be also equal to same, that is this is lower side band. So in general, you can say total power will be always equal to carrier power plus upper side band plus lower side band power. So now in this case, that means in case of AM, PT will be equal to PC, that's equal to AC square divided by 2 plus AC square MA square divided by 8 plus AC square MA square divided by 8, right? This is your total power equation. You just take AC square by 2 common, then you will get some value AC square by 2, then because base is same, powers will be, this will be added. So you just add these two, you will get twice AC square MA square divided by 8. This and this, you get 1 by 4. So ultimately value will be AC square by 2 plus AC square MA square by 4. Now, in this case, you take the value of AC square by 2 common, you will get a 1 plus MA square divided by 2. This is your final value of power equation, standard power value in case of AM. So you will say that PT is equal to AC square by 2, 1 plus ME, 1 plus MA square by 2. Can I say this AC square by 2 is nothing but your carrier power, right? बोलिए. Hello.
जी सर.
Yes, sir.
Because this is equal to carrier power. I wrote here this carrier power is AC square by 2. So that's what I am doing here. So this will be PT will be now equal to PC, or you can write AC square by 2. It depends. 1 by MA square by 2. This is your final value of the power, normalized power. Why normalized power? Because resistance value you normalize to 1, resistance value normalized to 1. Why? Because power is always equal to V square by R, or it's equal to I square by R. If you put the value of R equal to 1 ohm, then what you will get, P will be V square or I square. Or you can say P just equal to X square, means amplitude square. This is the normalized value of power because you have put the R equal to 1. So this is normalized power relation in case of EM. Now we will conclude some few points. Can I say here that carrier power is independent of modulation index? Because carrier power is equal to AC square by 2. Mu term does not appear in this. So yeah, MA term, that's also sometimes called mu. This does not appear in this equation. So you can say PC, PC, that means carrier power is independent of MA or mu. That means it's independent of modulation index. Now, what about sideband power? Sideband means lower sideband or upper sideband. This is total upper sideband or lower sideband power. This is equal to AC square MA square divided by 8. And this is dependent on modulation index. That means your sideband power it is dependent on MA. That means it's dependent on modulation index. Now we'll put few values. This is your standard equation. You just write, you just remember this. You can cram also this equation, but just have some concept how you derived the same equation. So this is your power equation relationship. Now put the value of MA equal to 0. If you will put MA equal to 0, that means this is the case of unmodulated signal. That means there is no modulation because modulation index is 0. Modulation, unmodulated signal, because modulation index is 0. That means 0% of modulation. So when you put the value of MA equal to 0, what you will get? PT is equal to PC 1 plus 0 square by 2. Then you will get, which implies PT is equal to PC. That means in this case, when there is no modulation, total power of your modulated signal will be equal to carrier power. That means this is unmodulation. That means no modulation happens in this case. That's one point you remember. That means in this case, there's no modulation because total power is equal to carrier power. Now, as you increase the modulation from 0 to 1, that means from 0% to 100%, what will happen? Suppose take the second case, this first one, take the second one, when MA value is equal to 1, that means 100% modulation. 100% modulation, then what you get? put the value of ma equal to 1, what you will get? Pt equal to pc. Are you getting me?
Yes,
Yes.
sir.
Okay. So this is ma square. This 1 square divided by 2. This value pt will be now equal to pc. That's 2 plus 3, 3 by 2. So your total power in this case will be equal to PC 3 by 2, 1 by 1.5 times carrier power. This is your total power in this case. Or you can say, carrier power in this case will be equal to 2 by 3 times PT. Carrier power in this case, carrier, because carrier does not contain any information is always in terms of sidebands, whether lower sideband or upper sideband. So carrier power is just a wastage of power. That means total power wasted in this case when modulation 100% modulation happens occurs, you can say is 2 by the 3 times. That means you can say this is nothing but 0.66 of pt. Now you can say carrier power in this case when modulation index value is 1, you can say this value is 66.6% of total power. Carrier power is 66.6% of total power. Then this is the wastage of power. Wastage, and that's power is a very important resource, wastage of power. Because carrier does not contain any information. Carrier does not contain any information. This does not contain any information. So this is a wastage of power. Now you can say that 66.6% of total power is distributed to carrier signal. That means remaining power is 33.3%. This is distributed, remaining power is distributed among upper sideband and lower sideband. That means total sideband power in this case will be 33.3% of total power. Right? Done?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So if you will say that what is the power, that's power contained by the lower sideband, you just divide the sideband power by 2. That means upper sideband power and lower sideband, they will be equal. So you will get 33.3 divided by 2. This is your power 1. Tell me the value. 16 point. Tell me. 16.6. Something like that. 16.6 or 7. Tell me. 33.
That's 6.
16.65.
6-5.
So this is your percentage of sideband power. That means upper sideband and lower side, because they are equal. 16.65. You add these two, you will get 33.3 power. This is your the value of sideband power information that's contained by this. Now, if if there will be if there will be mu equal to 0 in the first case, then total power will be equal to PC. That means carrier power then will be 100% of total power, and this is total wastage of power. Now you just write one definition. Now the percentage of power distributed to carrier is said to be the waste of transmitted power. That means the percentage of power distributed to carrier signal to carrier signal is always is said to be the wastage of power, because carrier does not contain any information, is said to be the wastage of power, is said to be the wastage of power, is said to be the waste of transmitted power. Just remember this. So when no modulation happens, if you transmit with no modulation, that means modulation index 0, then you're wasting the 100% of total power. That means total power is wastage. You just remember this. So for effective power distribution of power carrier signal, PC should be as minimum as possible. That means PC carrier power should be minimum. It should be very less minimum for effective power distribution of this should be minimum. All right. So in AM for effective power distribution, that is when mu is 1, you will get total power is equal to total power you got it in case of carrier, that means PC is equal to 2 by 3 times total power, and this is 66.6% of total power. That means carrier power in this case is this, and this is still wastage of power. Huge power is wasted. So this is the second, this is one of the major drawbacks in case of double sideband full carrier. So you can write that this is one of the drawbacks, one of the major drawbacks rather, one of the major drawbacks of double sideband full carrier, which is wastage of power. Now, anybody having any doubt till now, please tell me, then we can move on to the next topic.
Yes, sir.
Okay, we will start with now modulation efficiency. This is in continuation with this. And modulation index से हमने निकाला modulation efficiency. What do you mean with modulation efficiency? So modulation efficiency. So it's always is denoted by this, and this will be it's called as percentage efficiency, percentage modulation efficiency. So can be defined as it specifies percentage of transmitted power distributed to distributed distributed to sideband frequency distributed to sideband frequency components. That means the total power which is transmitted out of that very power, which power is distributed for the sideband transmissions. And because sideband is useful compared to the carrier signal, because sideband contains information, that's the reason we specify that means percentage of the transmitted power that's distributed to sideband frequency components. So percentage efficiency will be always equal to sideband power, sideband, sideband, sideband power divided by total power. Total power. So you have this will be equal to P sideband and total power into 100. And this will give you the percentage modulation. So percentage modulation will be equal to PC sideband power is equal to what? Because from this definition, PT is equal to PC 1 plus MA square divided by 2. This is carrier power and this is PC MA square by 2. This is total sideband power. This is sideband power and this your carrier power. So sideband power will be equal to PC MA square divided by 2 divided by total power. Total power is PT. Total power is PT and that's equal to PC 1 plus MA square divided by 2. Right? So you can say PC and PC cancels out. You'll get MA square divided by 2 plus MA square divided by 2, 2 cancels. So ultimately you will get value percentage efficiency is equal to MA square divided by 2 plus MA square. So this is your percentage of modulation efficiency, right? Percentage modulation efficiency. Now, suppose if MA value is 0, suppose for MA equal to 0, what will be your percentage modulation? Can anybody tell me? Put the value 0 divided by 2 plus 0 square 0. Percentage efficiency is 0, 0%. Done. That means sideband power will be 0% of the total power and carrier power will be 100%. इसका मतलब ये होता है कि your carrier power is 100% of total power and your sideband power is 0% of total power, because useful power is this very sideband power, it contains no power. That's the reason percentage modulation efficiency will be 0%. Suppose second value you take MA equal to 1 by 2, that means zero point 0.5. Then tell me this value percentage efficiency will be, or efficiency just will be, tell me, MA square divided by 2 plus MA square, right? Right?
Yes, sir.
Yes, sir.
Okay. Zero point 0.5 square divided by 2 plus zero point 0.5 square, and this will be finally equal to 0.11. If you will take its percentage, then you will get 11%. So you can say your total carrier power will be 89% of total power, and your sideband power that is useful, it will be 11% of total power. Done?
Yes, sir.
Okay. So similarly, you can calculate the value of this modulation efficiency when mu is equal to 0.707. Mu means MA. So similarly, calculate its value when MA is 1. Just tell me for 1, you just do this homework. Tell me for this, it will be MA square divided by 2 plus MA square, and it will be 1 divided by 2 plus 1. This is square, this is 1 by 3, right? So this will be your, that means this is equal to 33.3%. So you can say sideband power, total sideband power in this case will be 33.3% of total power, and carrier power will be rest, that remaining power, that will be 66.6%. And that's already done. ये हमने देखा ना, ये केस लास्ट केस अभी देखा हमने, right?
Yes, sir.
Okay, now we can do few questions, वो हम कल देखेंगे. One point to remember is that as PC is independent of mu, so its value does not change, but percentage of PC decreases as mu increases. एक point मैं लिख लेता हूँ, will make you understand this. Since PC, as PC means carrier power is independent of MA modulation index, so its value does not, its value does not change. Okay, so its value is not affected by the value of MA. As you increase MA or decrease, PC will remain constant. Means carrier power will remain always constant. But one point to remember is this percentage of PC, percentage of this in terms of modulation efficiency, PC, it decreases as your MA increases. It decreases as your MA increases. That's shown by this value. As MA is from 0.5 to this, it decreases, right? And this is the point to remember. Anybody having any confusion, question, please tell me. Then we can wind up the class. Okay.